Hi everyone, so today I'm going to start with question 8, and since we did away, we finished question 7, and we finished question 1 to 7, so today I'll just start with question 8, and then the question reads, find the area of a region bounded by the curve with the equation y is equal to fx and x axis, and the lines x is equal to A and x is equal to B. So what you should understand here is just the same. These questions are just the same with the previous questions here, and you should also to know that every integral that you make always leads you to finding the area of a given curve. So when you integrate this function here, given these two limits, you are simply finding the area of this curve and in between the two limits given here. Yeah, so now the difference that is just between the previous question which we had this one, because we are also integrating and we also had the limits given like that, but the difference that is there with this question is that for this one you need first to sketch the graph. Then after sketching the graph, rather the curve, that's when you will now be able to calculate the area. Yeah, so let us see how we can solve these questions. So I'm not going to solve all these questions. I'll just solve a few of these because I've seen most of these questions we solved them in we integrated them. It's just a matter of now just inserting the limits. For example, this one here, we solved it at one point, so when you recall or when you solve it again, you just have to put these limits there, then you are going to find the area. Yeah, so again, which other question? Yeah, for these others I think I can solve it. Even this one we solved it. It's just a matter of inserting the limits. So what you do here, you first have to look at your function here. Yeah, so you can, if you want to draw this function, by looking first, by looking at it, you want to sketch, you can see that the coefficient of x squared there is positive, which implies that this has a minimum value. So meaning the curve is going to come out something like it's going to look like this. So the curve is going to look like, since it has a minimum value, it has to look like this. And then we've been given the limits. Yeah, we've been given the limits, which are x is equal to 3 and A is equal to 3 and B is equal to 5. So what you now need to do is to sketch this given curve. Actually for this question it's a little bit straightforward, so if you want you can't even sketch the curve. If you want you cannot even sketch the curve, you can just go direct in finding the area of this given curve. So let us find the area. The area is going to be just the integral of that. So the area is just equal to, so A is just equal to the integral of f of x with respect to x, and then given the limits b and a, that is the area. So to find the area of this expression here, we first have to integrate that. So when we integrate that, we're going to have, when you integrate x squared, you're going to have x to the power 3 over 3 and then minus 4x. Then we just now have to plug in the limits. The upper limit there is 5 and then the lower limit there is 3. So now to solve this, we're going to first plug 5 where there is x there. So we're going to have 5 to the power 3 divided by 3, then minus 4 times 5, and then we put these in curly brackets, then we say sub, and then we say minus again. We'll have, while there is x, we put 3, so we're going to have 3 to the power 3 over 3 minus 4 times 3. So this is just a matter now of simplifying the expression, and then what we're going to get as the answer is the one that we're calling our area. Simplify that, you get so this part here will give you 65 over 3, then this last part here will give you negative 3. So this, now when you simplify it further, you get 65 over 3 plus 3. So here you're going to have, this is just the same as 65 plus 9 there, which gives you 74 over 3. So this is your solution. Of course, don't forget to put your units there. Just write units squared, since it's the area that you're finding. Yeah, so this is how you find the area. This is how you find the area given the limits. Yeah, so this is how you find the area when you've been given the limits. Let's proceed. Let's check the next question. So the next question is x squared minus x. You also do the same. You first integrate it. So when you integrate that, yeah, so even this question, you do the same. This one here. So for this one, you also integrate that. When you integrate that function, the integral of x squared minus x with respect to x, then the limits that are going to have is 1 and negative 1. Yeah, the upper limit is always supposed to be greater than the lower limit. So when you integrate that, you get this will give you x to the power 3 divided by 3 minus x squared divided by 2. So this is how it's going to be, and then you have your limits there. So from there now it's just a matter of plugging in the limits, then we find the area. So we plug in, we're going to have, when you put 1 there, we're going to have 1 over 3 minus, when you put 1 there, you're going to have 1 over 2. Then you have your minus there. We now put in negative 1. When you put negative 1 there on x, you get negative 1 over 3 as your answer. Then minus, when you put your negative 1 on x squared there, you put on x, you have 1 over 2 as your solution. So we can see that when you expand this negative, when you open the brackets of this negative, you are going to have 1 over 3, then plus 1 over 3, then you get negative 1 over 2, then plus 1 over 2. I've just expanded that and paired terms which will make it easier for me to simplify the expression. So we can see that this will give us a 0 there. Then apart from there, 1 over 3 plus 1 over 3, you get 2 over 3. So this is going to be your area for the second question there. And you write your unit squared this side. So this is what we're going to have. So let's move on to the next question. This is how you solve this question. Let's move on to the next one. So this was our area. Let me just put A this side. Alright, so let's proceed to the next question. The next question is saying cos x, f of x is equal to cos x. So there is also just a matter of integrating this. So to find the area of that, we're going to integrate cos x. So we're going to integrate cos x. And then the upper limit there we've been told is pi over 4, because pi over 4 is greater than pi over 6, and then the lower limit is pi over 6. Then we're integrating this with respect to x. So here, before you even start integrating, you can sketch you can try to sketch this just to see how your graph is going to be moving. So your graph is going to move in this way. We know that our amplitude there is just 1. Yeah, that is going to be our amplitude. It's 1. And then our period there is equal to 2 pi. So how is this going to move? So I'll put 2 pi there. Then the half of 2 pi, of course, it's pi. The half of pi is pi over 2. And then the half of so pi plus pi over 2, there you get pi plus pi over 2, you get 3 pi over 2. So this is what you're going to have. So now it's just a matter of sketching this. Then since cos there is positive, meaning it's going to start like that. It's going to move like this. Alright, so this is how it's going to move. This is how it's going to be. Now let us try to point out to see where our limits are. A is equal to pi over 6 and b is equal to pi over 4. Let's just see where that is going to be. Yeah. So pi over 6 is simply 30. Yeah, pi over 6 is simply 30. So where is 30 going to be? Somewhere, I'll approximate somewhere there. And then pi over 4 is also is 45. Yeah, 45. So it's also going to be there, because this other part is just this one is 90, this is 180. Yeah, so 45 can be there, then 30 can be there. So the area that we're trying to find is this. So here what I was trying to check is to see where I was trying to check where the graph is going to be, because what you need to note is that if you have your graph, if you're finding this area here, you are always supposed to put a negative outside this side. If you are finding the area, if you have something like this, and then you are finding this area, this is also supposed to be a negative. So this and that is supposed to be a negative. So if you have down or this side, you are always supposed to add a negative. But in this case, our area is on the positive side, so there's no need of us putting a negative. So here it's just a matter of integrating that. So let us integrate cos x. Of course we'll get sine x. So when you put sine x there, we put our limits, which is let me just write them as in degree form. So 45, and then we have 30 this side. So to find the area, we just say area is equal to sine 45 minus sine 30, and we all know these are special angles. Sine 45 is nothing but the root of 2 over 2 minus sine 30, which is 1 over 2. So it's a matter of simplifying these expressions. So you're going to have the root of 2 minus 1 over 2. You put them in brackets, and don't forget to put your units outside. So this is how you find. So in this case, sorry, I was supposed to put a positive since my area is on the positive side. So this is how you find the area. So area is just the integral of a given function through the given limits. Yeah. So you also do the same to this question here. You integrate this. Of course, you can see that this can be integrated using either by parts or you can use okay, let me just integrate it, and we'll also find the area. Let me just finish all these questions. So we have our f of x being equal to x e to the power x squared. X e to the power x squared. So this is our f of x. And then apart from this, the other thing that we have here is the limits there. So meaning we integrate that to find the area. So area is just equal to the integral of x e to the power x squared with respect to x. So how do you integrate this? Of course, the limits are, we have -1 there, and then we have -2 there. So when you integrate this, you have something like, if you make this as your u, so meaning you have the integral, of course there is x this side. You have the integral of x e to the power x, and then x squared there, then divided by 2x. Sorry, this is not supposed to be x squared. If you make this as your u there, and then du this side, you see that and that being cancelled. So here it's just a matter of integrating e to the power u with respect to u, which will still give you half e to the power u, which is just the same as half e to the power x squared. And then the limits there that have been given are -1, -2. Don't forget to put your limits, -1, -2. So -1, -2, -1, -2. So these are your limits. So here again, it's just a matter of plugging in the values of x. So the upper limit there is -1. So you put -1 where there's x there, you get a half e raised to power 1, because negative 1 squared will still give you 1. Then for the second part there, you subtract say minus half e raised to power negative 2 squared, you get 4. So here it's just a matter of simplifying that to find the area. So when you simplify that, you have your solution being equal to e minus e to the power 4, everything divided by 2. Yeah, and this you put unit squared. Yeah, so this is how you find the area. It's just as simple as this. Yeah, so if you discover that your answer that you're getting will be a negative number, you just add a negative this side, put negative outside throughout your solution, you put a negative so that your final answer becomes a positive. So of course this one they were supposed to put a negative because e minus e to the power 4 you get a negative number. Then area is always positive and not negative. So let us proceed to E. So this question here is straightforward. It's just the same as this one here. It's just a matter of simplifying. It's just a matter of integrating the function and then plugging in those limits there. So that same applies to this. So this one here you do the same. So at least I've done one on trigonometry, I've done one on algebra and on exponentials like that, which implies that the remaining two are just simple. So you can try the remaining two to see if you are going to manage them. You can try them on a separate paper and then try to send the solution and check to see what you're doing, if what you're doing is right or wrong. And then if you have made a mistake anywhere, I can correct you or send you the correct answer. Let's check the next question. So here this question is saying sketch the graph or sketch the region bounded by the line y is equal to 2, the curve y is equal to 6 minus x squared, and the x-axis. Find the area of the region R. So this one is also straightforward. This question is also straightforward. The way you solve this question is they are saying we first have to sketch. So how do we sketch this? So by looking at the coefficient of x squared there, it's negative, which implies that the graph is going to be a maximum. I mean the curve is going to have a maximum value. And then apart from that, you can also check the line there. That's a positive line. The line there which is y is equal to 2. So let me just be writing what I'm talking about here. So we have this curve and then we have, okay, before we write our line there, let's try to sketch that. So to sketch this curve here, you first have to find the x-intercepts and the y-intercepts. So to find the x and the y-intercepts, we know that in the x-axis dy dx is equal to, in the x-axis y is equal to 0. So in the x-axis y is equal to 0. So to find the x-intercepts, we put 0 where there is y. In this equation where there is y, you put 0. Then you write your equation like that. So meaning your x values there will just be equal to plus or minus the root of 6. So meaning we have our x values to be plus or minus the root of 6. And then already we know to say our So we know to say our our x value, our curve here is supposed to be a maximum. So the other thing that we also need to find is the y-intercept. The x-intercept is just the point where the curve cuts the x-axis, and then the y-intercept is a point where the curve cuts the y-axis. So how do you now find that? It's also straightforward. How do we do that? So in the y-intercept, for the y-intercept, we know that in the y-axis x is equal to 0. So this curve, in short, is cutting the y-axis at 6, because when we replace x with 0, we're just going to remain with 6 there. So the y-intercept is just equal to 6, and then the x-intercept is just equal to, so I'll write my 6 there, and then I'll put my positive root of 6 there. I'll also put my negative root of 6 there. And then let us now find the maximum. So we know to say, we find the maximum value. So we know to say, you can either use, at maximum we know that x is nothing but equal to negative b over 2a. That is at maximum. So at maximum or at minimum, the value of x is equal to that. So you can either use this to find the value of x at maximum, or you just say at maximum dy dx is equal to 0. So at maximum dy dx is equal to 0. So what is our dy dx? When you differentiate this, the dy dx there is just equal to negative 2x. When you differentiate this expression, you get negative 2x. So when you equate this negative 2x to 0, you get your value of x being equal to 0. So at maximum, x is equal to 0. Let us now find y, where x is equal to 0. So our y value when x is equal to 0, we just replace 0 while there's x there, meaning we're going to find our y being equal to 6 minus 0 squared. So meaning the coordinates of the turning point will just be equal to 0, 6. So these are the coordinates of the turning point. So the turning point occurs at this point, at this same y-intercept, but it's not always that happens. So in short, our graph is going to come out like this. So this is how it's going to come out. But remember, we've also been given this line here, which is 2. So I'm going to draw my line 2 there. So I'm going to draw it like that. So it's supposed to pass at 2, okay, like that. Then they are telling us to say we find the region R bounded by the line y is equal to 2 and the curve y is equal to 6 minus x squared, and the x-axis. Find the area. So in short, the line that is bounded, the region R that is bounded by that is just nothing but this one here. So we're finding the area for this region here. So now, how do you find the area of that? We have this line y is equal to 2. We also have this curve y is equal to 6 minus x squared. So let us now start finding the area, because we have found the region which we actually need to find the area for. So I'm just remaining with finding the area of that region. So let us now see how we calculate the area for that region. Simple and straightforward. So it's just as simple as drinking water. Let us now find the area. So the area is just given by and the integral of the curve or of the line that is on top of the other. So which one is the line which is on top? Of course we know that the line which is on top is just this curve, because it's passing on top of this line y is equal to 2. So we're going to start first by finding the integral of we're going to start first by finding the integral of y, so of this line which is on top, which is x minus x squared, 6 minus x squared. And then what we do is we're going to subtract the integral of this, which is 2, the integral of the line which is below the other, so which is 2. Of course, don't forget that we are integrating this with respect to x. But one may start asking themselves, where are the limits? Where do we get the limits now from here? So you get the limits by solving these two equations that we've been given simultaneously. So we know to say y is equal to 2 and then y is equal to that. So meaning this same y can also be put there. In short, what I'm trying to say is where there is y, we can put 2. So we're going to have 6 minus x squared, like that. And then to find the limits there, you take this 6 to the other side there, so you get -4 this side being equal to negative x squared, which implies that the value of x will just be equal to plus or minus 2. So this is going to be the value of x. So that is going to be the value of s. So these values of x are the ones that we have as our limits. So our limits there will now be equal to, we are going to have -2 there, and then we have +2 there. So these are the limits that we're going to have. So the area that we're going to find now is this part here. What is the area we're looking for? So let me just erase this. Okay. Alright. So the area that we're looking for is in this region R. So now it's easier for us now to find the area. So we have our limits there. We have 2 and -2. We have 2, -2. So area is now equal to, so the area is now equal to, the area is now going to be equal to, we can join the two, since we know that the integral and the limits are just the same. So we can join the two. We can say 6 minus x squared minus 2, and then we say the x outside. So to find the area, we're just going to find the integral with the given limits 2 and -2. So 6 minus 2 there, you get 4. 4 minus x squared dx. So this is what we're going to integrate to find the area. So area will now just be equal to 4 minus, area is now just going to be equal to 4 minus x squared, which is we just integrate that. So integrating that will give us 4x minus x to the power 3 over 3. And then we don't forget to put our limits, which is 2 and -2 there. So you put your limits there to find the area. So when you put your limits, you discover that your area will just be equal to, so this will be 16 over 3 minus, 16 over 3 minus so this is going to be minus -16 over 3. Yeah, so when you add the two, you can see that it's just the same as writing a plus there. 16 over 3 plus 16 over 3, which gives us 32 over 3. So 32 over 3 units squared is the area. Yeah, is the area. So this is the area of that question there, that given question. Let's proceed to see what B is. So this is supposed to be B here, not C. So this is the area for this question. So B is saying sketch the region R bounded by the curve y is equal to x squared plus 2, the x-axis and the y-axis, the line joining the point, and the line joining the point 2, 6 to the point 26, 0. Find the area of the region R. So here we've been given the curve here, which has a minimum value. Just by checking the coefficient of xy there, you can tell that it has a minimum value, meaning it's going to come out like this. It's going to come out like this. And then the x-axis and the y-axis and the line joining the point 2,6 and 26,0. So when you've been given this these two points, this one and that one, it's easier for you to find the line. And then how do you find that line? So the way you find that line is by using this formula. I'm sure you learned this at high school, even last semester, where you say y minus y1 being equal to m and then x minus x1. So we first have to, this implies that we first have to find the gradient m there. So gradient is just given by y2 minus y1 over x2 minus x1. So this will now give us, so our y1, we can choose our y1 to be 0. So we'll have 0 minus 6 over 26 minus 2. So this is going to give us negative 6 over 24, which is just the same as negative 1 over 4. So this is going to be our gradient, negative 1 over 4. So our gradient is negative 1 over 4. So let us now find the area, the line there. Okay. So we will say y minus y1 is y1 is going to be 0 there. So say y minus 0 is equal to the gradient is negative 1 over 4. And then times x minus x1 there is 26. You can choose any of the two coordinates to use as your x1 and y1. So our equation will just now be equal to negative 1 over 4 x plus 26 over 4 is just the same as 13 over 2. Yeah, so this is going to now be, going to be your equation. So they are saying find the area of the region bounded by this curve and this line there. So it's very simple. So first of all, we can find the limits since we've not been given the limits. And how do you find the limits? You find the limits, so you find the limits, yeah, so you find the limits are just the 2 points where the curve and the line are going to meet. Same applies to that question that we had, which looked like this, if you remember very well. So the limits were actually supposed to be, so that 2 and -2 that we had, -2 was supposed to be there, so it was coming out like this. So at this meeting point, that's where we have our limits, where the curve meets the line. Okay, let's now find the limits for our question here. So the limits, we're going to solve this equation and this one simultaneously. So we're going to have -1 over 4x, and then plus, let me just write 26 over 4, which is just the same as 13 over 2. 26 over 4, this is equal to x squared plus 2. So yeah, we can now solve this simultaneously. We can now solve this. So this will give us -1, -x plus 26. When I simplify it by multiplying everything by 4, is equal to 4x squared plus 8. So we can take all these to the other side of the equal sign there, which implies that we're going to have 4x squared plus x, and then we'll have 8 minus 26, you have 18 plus 18. Oh, sorry, minus to be a negative. 8 minus 26, you have -18. Then everything will now be equal to 0. So here it's just a matter of finding the values of x by solving the quadratic equation. How do you do that? So 18 times 4 is nothing but 72. So the product here is -72, and then the sum is 1. So which two numbers that we can add to get 72? When we multiply, we'll get -72, and then when we add, we will get +1. And of course these numbers are nothing but, so these numbers are 8 and 9. So when we multiply 9 times 8, we get 72, and then when we add them, when we add -8 plus 9, you get so let me start with -8 here. You will get +1, -8x plus 9x minus 18 minus 18 is equal to 0. So here you get 4x as your common, and then you get x there minus 2, then there plus 9 outside, meaning you have your x minus 2 there as well. It is equal to 0. So in short, your x there will just be equal to 2, and then your other x will just be equal to -9 over 4. So these two values of x that we found are these are the points where, these are the limits. In short, these are the points where the curve is meeting this line here. So after finding these 2 points, we can now go on to find the x-intercept and the y-intercept. And then when you look at the curve, our curve that has been given here, we know that in the x-intercept, the value of y is equal to 0. So when you replace where there is y with 0, when you replace where there is y with 0 there, you can see that after finding the value of x, you get a complex number. And then when you get a complex number, it means that the curve has no x-intercept. So it's just a matter of now finding the y-intercept. So the y-intercept, what I was explaining was that when you put 0 there where there is y, and then try to find the value of x, you discover that your x will be a complex number. When you take this 2 to the other side of the equal sign, you get -2. The square root of -2 is 2i, is the root of 2i, which is a complex number, which implies that this curve has no x-intercept. So to find the y-intercept now, you just put where there is x 0. We know that in the y, x is equal to 0. So when you put 0 there, you discover that your y-intercept will just be equal to 2. So meaning the curve cuts the y-axis at 2. So it's easier now for us to draw this. So when you draw the curve like that, we know that this curve has a minimum value. So I'll draw it this way. It has a minimum value, and then it cuts the, so it's like this. It has a minimum value. Now let us try to find the minimum point, meaning this point here. Let us try to find this point. But I already know that it cuts the y-axis at 2, and then it does not cut the x-axis. Then let us also try now to find let us now try to find the minimum value, which is this point. How do you find that? It's also called the turning point. So at the turning point, we know to say the value of x is just equal to -b over 2a, or if you want, you can just differentiate that and then equate it to 0. So when you differentiate that, so -b, what is -b? So it will be 0 over 2, my a there is 1. Yeah, my a there is 1. So you discover that your x value there will be 0. Then the y value there is just going to be equal to 2. When you put this 0 where there is x there, yeah, you put the 0 where there is x, you put 0 where there is x there, you discover that you put 0 where there is x there, you discover that your y is going to be 2, meaning the turning point will just be equal to 0, 2. So in short, how the curve is going to look like, it will not come out as this, but it's going to appear something like it's going to appear like this. So I know to say it's cutting the y-axis at 2, and then at this same point too, that's where we have our turning point. So we're going to have our curve looking like that. So it's turning at this same point, then goes up, and then the line which we've been given here, it has a negative gradient, which implies that it's going to be like this. This line is going to be like this. And then at these 2 points where the line and the curve are meeting, that's where we have our -9 over 4, and this point here, which is +2. So now the region that we're trying to look for is this one here. This is the region R that we're trying to find. So now to find the area of this, it's now even easier. Let us try to find the area. Let me just erase this. Okay, so the area here is just going to be equal to, remember what I said, to find the area you just find the integral of that given the limits 2 and negative 9 over 4, 2 and negative 9 over 4, so negative 9 over 4, and then you subtract the curve which is on top, you subtract the curve that is under or that is down from the curve that is on top. So my curve which is on top is just a line. Yeah, so this line, if you remember very well, was just equal to negative 1 over 4 minus there was x there, then minus 13 over 2. Sorry, it was a plus here. 13 over 2. This is the line that we had found. Yeah. So we're going to subtract this line, the curve minus the line. Then the curve is y is equal to x squared plus 2. So this would be x squared plus 2 minus negative 1 over 4 x plus 13 plus 13 over 2. Then we'll do this by integrating this with respect to x. So you do the same there. You're going to have your x squared there. So you have your limit 2, your lower limit negative 9 over 4. So you have your x squared there, and then when you subtract these 2 minus 13 over 2, you get negative, let me just write it here, negative 9 over 2. And then let me also subtract this. We have 0x there minus negative 1 over 4x. So it's just going to give us positive 1 over 4x. So integrating this with respect to x. So now it's just a matter of finding the integral now. So the integral will give us x cubed to the power x cubed over 3. And then this will give us 1 over 4x squared divided by, so 1 over 4 divided by 2, you'll get 1 over 8. You get 1 over 8, and then this negative 9 over 2, when you integrate that, you just have x being introduced there. Don't forget to put your limits, then negative 9 over 4. So to find the area now, it's just a matter of adding. You first put the 2 there, put the 2 in there, and then find the answer there, and then you subtract. You put negative 9 over 4 there, find the answer there, and then find your area for, this region R. So it's just as simple as that. Yeah, you can simplify this from this point. I've left it here because I know no one by this time can fail to simplify an integral given 2 limits. So let's proceed to the next question. So this question is also simple. Find the area enclosed between this curve and that curve. So in this, the difference between these two, the previous questions and this one, is that in the previous questions we were given a curve and a line, like this one, a line and a curve. But on this one we've been given 2 curves. So here it's just a matter of knowing which one is on top and which one is down. So how do we get to know that? You just find you just need to find the minimum. The the minimum point and the maximum point. Here, how do you know which is minimum and which one is maximum? So you look at the coefficients of x squared. Here our coefficient of x squared is greater than 0, meaning it has a minimum value, and then for this other one it's less than 0, so meaning it has a maximum value. So this is how the curves are going to look like. So this one is going to be our y2, which is this one. Then this is going to be y1, which is this one. Okay. So here it's just a matter of finding the area. But before we find the area, we need to find the limits. And then the limits are just these 2 points there. This one and that one there. So we have our A there and then our B there. So how do you find the limits? It's just by solving these two equations simultaneously. And then how do you solve them simultaneously? We know that this y is equal to that and this y is also equal to that. Then this y and that y are just the same. So meaning where there is y, I can put that. So in short, what I'm trying to say is 10x, where there is y, you put 10x minus x squared. And then you say this equal sign is equal to 2x squared plus 3. So we pair the like terms here. You have x squared, and then you are going to have this 10. This 10 when it goes to the other side there. Sorry, let us do this. Let me pair the like terms and write the final answer. So this 2x plus this 2x squared plus x squared there, you get 3x squared. And then this 10 will become a negative 10x when it crosses the equal sign. And then you have a positive 3 like that. It's equal to 0. So here it's just a matter of solving this quadratic equation. We need to find two numbers. When we multiply them, we get 9. When we add them, we get negative 10. And I think it's negative 1 and negative 9. So we can write 3x squared negative x and then negative 9x plus 3 is equal to 0. So here we're going to say x, we factorize x there, you get 3x minus 1, then minus 3. When you divide this into that, you get 3x minus 1 being equal to 0. So 3x minus 1, and then we have x minus 3 being equal to 0. So our first value of x there will just be equal to 1 over 3. Then the other value of x will just be equal to 3. So our a there will be 1 over 3, and then our b will be 3, meaning our lower limit is 1 over 3 and then our upper limit is 3. So here it's just now the matter of integrating. So to find the area, we get the curve which is on top minus the curve which is down. So the integral of which one is the curve on top? The curve on top is y2, which is this one here. So we're going to have 10x minus x squared minus the curve that is down is 2x squared minus 3. And then we're integrating this with respect to x. The upper limit is 3, the lower limit is 1 over 3. So the area there will give us the integral of 1 over 3 there. So this will be negative x squared minus 2x squared. This will give you negative 3x squared, then plus 10x, then of course this negative times that negative 3, you get a positive 3. So you also just integrate this and then plug in the limits to find your solution. So we integrate this, we're going to have, let me just do this. So we integrate that, you'll get negative x to the power 3. Since this will be positive 2 plus 1, there will be 3 divided by 3, you get that. And then you have plus 5x plus 3x, or 5x squared, sorry, then plus 3x, like that. Actually here there is no need of putting these brackets, you just put the limits outside. So here it's just a matter of putting in the limits and finding the solution there. So you just have to find the limits. First you plug in 3 where there is x, you get the answer, and then minus, you plug in 1 over 3 where there is x, you get the answer, and then calculate the area there. So this is how you calculate the area of any given curve and the line. Yeah. So the area, the region enclosed is that. But this is not a sketch, by the way. I was just illustrating on how you sketch this. This is not a sketch, but you've been taught to sketch that. So meaning you need to find the x-intercept, the y-intercept for each of these two curves. You find the x and the y-intercept. Yeah. So it will be something like this, I think. Find the x and the y-intercept for these two curves, even the minimum and the maximum values. You know that at maximum or at minimum the value of x is equal to negative b over 2a. Or if you don't want to use that, you can say at minimum or at maximum dy dx is equal to 0. So meaning you find dy dx from this and equate it to 0 to find x at the minimum or at the maximum point. Same applies to this. You find dy dx of this expression and then equate it to 0 to find the value of x at the minimum and at the maximum point. Alright, so thank you very much for watching. This is how you solve the areas of given lines and curves. So we've ended on question 9. The next tutorial video that I'm going to make, I'm going to start with question 10 to find the volume generated by a revolving curve. Yeah, same applies to question 11, talks about the same thing. Yeah, it's talking about the same thing, and even question 12 is talking about the same thing. Then we'll call it the end of this tutorial sheet, so that we start the next tutorial sheet, which is about conic sections. So see you in the next tutorial video. So I'm going to post this now, and then maybe just 2 or 3 hours from now I'm also going to post the remaining 3 questions. See you in the next tutorial video.